the end, it swayed but didn't fall. Perched atop the largest shake table in the world and subjected to a massive simulated earthquake, this 6-story wood-frame condominium stood tall, and the success of the test may lead to safer, taller wood-frame building construction in earthquake zones.
The earthquake that's being simulated here is effectively an earthquake that would occur on average only once every 2,500 years. So it's a very, very strong earthquake, much stronger than we currently designed for in the U.S.
Colorado State engineer John Lindt leads a team that's developing new ways to build mid-rise, wood-frame buildings that can stand up to earthquakes. In many earthquake-prone areas of the U.S., wood-frame buildings taller than 3 stories are uncommon, and building codes generally limit such construction to just 4 stories. Lindt hopes validation of the new design techniques could safely push those building codes to 6 stories or even taller.
The detailing that we've incorporated into the structure is not difficult, it's not especially expensive, it's just an engineered system, and we can certainly put this into all of our structures built in high seismic regions and expect that these structures will perform well in earthquakes and that indeed lives can be saved.
To test their new design, Lindt turned to E-Defense, a remote shake table facility in Miki City, Japan. It was the grand finale in a series of shake tests on wood structures funded by the National Science Foundation's Network for Earthquake Engineering Simulation. This shake table is not only the largest in the world, but it's triaxial, meaning it can move in 3 directions at once. That's key for simulating an earthquake as realistically as possible. When a test is held, it can be felt in the surrounding area, Shimizu said. They decided to build it where there are no people around, and that is why it is so isolated. They actually flattened a mountaintop and dug a crater and put 22-foot thick concrete around it to try to limit the effect on the surroundings. The building is outfitted with over 300 sensors that provide researchers with exhaustive data on how it holds up to the simulated seismic forces. One major design innovation is a backbone of steel rods called an anchor tie-down system.
The steel rod that you see behind me provides the overturning restraint for the entire building. It goes up from story to story, effectively making a continuous steel rod from this level, which is the first level, all the way to the roof. Here you can see strain gauges, and what we're measuring is by getting the strain in the steel, we know how much it's elongated. And what this does is this system prevents the overturning of the entire building.
Another innovation they are testing is called performance-based seismic design, a nail pattern technique that distributes stiffness throughout the construction and makes it stronger.
Most of the walls in this building are regular light frame wood walls. What we see here is something called a double mid-ply wall. The double mid-ply wall has sheathing inside of the studs, and then the nail goes through the sheathing and through a stud on each side. This particular wall actually has the capacity of about 4 wood shear walls, and there's 2 in this building, 1 on each side.
Just getting the building materials to Japan and erecting the condo proved to be a huge logistical challenge. And as always, the devil was in the details.
There were also some smaller challenges like language barriers with the carpenters going both directions, trying to explain the difference in construction methods to them.
At last came the moment of truth, the simulated 7.5 magnitude earthquake. The test was a satisfying payoff for years of work for Lindt.
What we learned from this test that you just saw is that a 6-story light frame wood building, if designed correctly, and in this case designed using performance-based seismic design, you can use that philosophy, you can design a 6-story structure, and honestly, in looking at that, I think we can do an 8-story.
Post-shake inspections confirmed there was no significant structural damage to the building. It's a success story that may pave the way for a new era in wood frame construction in earthquake zones. For Science Nation, I'm Bruce Burkhart.